Yes, good evening, my dear students and the entire community and the real aspirants who wrote GATE Electrical Engineering today. I hope you wrote well, and we as a team from ACE Engineering Academy would be discussing the memory-based questions, and I myself, B.S. Krishna Verma, faculty in ACE Engineering Academy, with my colleagues and best friends and one of the best team in electrical engineering, would be giving you the tentative answers based on the available data from the memory. These solutions may not be so accurate, but with lot of information shared from the community and the students of ACE Engineering Academy, we would like to give you the best possible answers. However, in few more days, once the official paper is released from the IITs, we will come with accurate solution and you can download the PDF also. So here is my team. So we welcome you to this live session of Solutions to GATE Electrical Engineering 2024. Yes, now before we start the session to discuss each and every subject and approximately the number of questions, and with the data what we got, we are trying to give you the most accurate available data. Now this is GATE 2024, you know, one of the most prestigious exam that an engineer can write in electrical engineering. And of course this is purely memory based, I want to highlight this, okay? So data may not be 100% accurate, but definitely with the available data, we will give you the best possible solution. And now before I start, yes, this is the division of marks and the type of questions for each subject. As you observe, this time MCQs 37, numerical, okay? Yeah, analysis type is 23, MNSQs 5. So multi-select questions also 5 came, that is the data we got. And as you observe, see, electrical circuits, total 5 questions came. Electromagnetic fields 3, signals and systems 7, electrical machine 6, power systems 5, power electronics 7, electrical and electronic measurements 2, digital electronics and microprocessor 3, analog electronics 3, control system 6, engineering maths 8, general aptitude 10. Okay, this is the data and the accurate data, and total 65 questions. Okay, you can observe again as you observe, you see power electronics 7, power system 5, 6. These are our core subjects. But this time you see signals and systems, total 7 questions came. And however, network 5, in that 3 2 marks, 2 1 mark. Okay, so it is an evenly divided paper, and engineering maths and aptitude are standard. Okay, so overall if you see this time, this power electronics, I would say signals and systems and controls dominated apart from core subjects. And these are the where the type of questions came in these subjects. Then I myself would like to discuss directly the memory based questions of this subject, that is electrical circuits. We call network analysis for ECE, but electrical circuits for EEE. Questions for easy. So I got 3 accurate data questions, but 2 questions came recently, just in few minutes back, but data was not accurate, but I will discuss with you. In that regard, now this is the first question in electrical circuits, that all elements are ideal. The power delivered by 10 volt source is dash. So here all elements are ideal. You know, network theory or circuit analysis, we discuss our ideal resistor, ideal inductor, voltage source, current source. And the power delivered by 10 volt source is dash. He is asking power delivered by 10 volt source. But he gave the options like, is it 100 watt? Depends upon alpha, because it is alpha ohms given, 0 watt or 50 watt. Okay, power delivered by 10 volts. Now interestingly, to know the power delivered by 10 volts, I need current through it. Okay, current into voltage is power. But alpha is a resistance which I don't know. So everyone got something like, you know, in a confused state, how can we find without alpha? But let us do nodal analysis. Now if I do nodal analysis by taking this as reference node and let this be voltage V. Now if I write nodal equation, yes, if I write directly nodal equation, V minus 10 by alpha, this is V by 1, and this is directly minus 10 amps is equal to 0, because in nodal analysis we write KCL. V minus 10 by alpha, V by 1 minus 10. So if you solve, interestingly, yes, if you take alpha as LCM, V minus 10 plus alpha V minus 10 alpha is 0. Interestingly, if you take V, 1 plus alpha is equal to this side, you take 10 common, again it is 1 plus alpha. So interestingly, you see, this is nothing to worry, and directly V is 10 volts. So nodal analysis, the node voltage is 10 volts. So from nodal analysis, this node voltage itself is 10 volts. So he gave data to confuse you. This is data which is not really affecting the system, but after writing KCL, interestingly this came 10. Now with reference node, this is also 10 volts and this is also 10 volts. When these two are 10 volts, potentials are equal, potential difference 0, current cannot flow through this branch or this element. When current cannot flow, this is 0 amps. So here it is 0 amps. So current cannot flow in this branch. So here interestingly, with the available data, though alpha is not given, but after writing nodal analysis, this node voltage came 10. This is already 10 volts, 10 volts. So potential difference is 0, current cannot flow. So indirectly current is not flowing through 10 volts. So power delivered by 10 volts is indirectly 0 watts. So 0 watts. So it is a very interesting. So if you dare to do without considering alpha, you will get the answer. But if you still think about alpha, there is a problem that you may get into the trap. But directly writing node, interestingly answer is independent to alpha. We got answer as 0 watts. So power delivered by 10 volts is 0 watts because current through it 0 amps. Okay. Then if you go to this, the total number of junctions. Junctions are nodes. Okay. We call it as junctions, but the classical way to answer is nodes. What are nodes? Node is a point of interconnection or junction between two or more components. See, node is a point of interconnection or junction between two or more components. Even between two elements is a node, but that is called simple nodes. And any connection or junction with more than two elements is called principal node. So it's simply asking number of junctions. So this is the data we got. So simply number of junctions, but according to definition, even between two elements is a node, but that is a simple node. So if you observe, see here interestingly, this junction is connecting only two elements, so it is simple node 1. This junction is connecting only two elements, so simple node 2. And interestingly, this node is connecting only two elements, so simple node 3. So simple nodes are 3. But what are principal nodes? Yes, any junction connecting more than two elements are called principal nodes. So this is of course principal node 1. This is principal node 2. Okay. And this is principal node 3, principal node 4. Okay. Then this is principal node 5. And this total is single principal node 6. So yes, with the available data shared by our ACE Academy students, I would say there are 3 simple nodes. Simple nodes connect only 2 elements. Okay? But any node connecting more than 2 elements are called principal nodes. Principal nodes are how many? This is connecting 3, this is connecting 3, this is connecting 3, here this is connecting 3. Okay? And interestingly, here it is a single node. Okay? 1, 2, 3, 4 elements and 5 elements. So, this is also principal node. So total 3 simple, 1, 2, 3 and 6 principal. 1, 2, 3, 4, 5, yeah, this is 6 and this is 5. So, 3 simple, 6 principal, total nodes are 9, But if the question would have been only principal nodes, yes, it would have been 6. And in node analysis, we neglect simple nodes and one of the principal node is taken as reference, so only 5 equations we write. Because simple nodes we can neglect in node analysis, and out of 6 principal nodes, one of the principal node we take as reference, then 5 equations are the minimal equations. Okay? Yes, that would have been. And even in mesh analysis also 5 equations would have been there. But according to the question with the data available, total nodes are 9. 3 simple, 6 principal. Then you see this, the circuit shown, the switch is open in steady state. After the switch closed, determine the time constant. Now first of all, this is an RL circuit. Yes, this is an RL circuit. Now in an RL circuit, the time constant is L equivalent by R equivalent. Tau is L by R. What is time constant? It is the time taken by the response to reach 63.2% to its final value. That means this is a transient, because once the switch gets closed, currents change, because resistance has changed, everything will change. But it takes approximately 5 time constant to reach the next steady state. Approximately 5 time constant to reach the next steady state. But what is time constant? It is the time taken by the response to reach 63.2% to its final value. Okay? So that time constant is asking. Now let us simplify based on the available data. So here let us simplify. So once the switch has closed, now see the data. Ideal current source we open. Okay? Ideal current source we open. Okay? And these are resistors. And these are however inductors. Okay, so tau is L by R. So if you observe, switch has closed, these two are resistors. Of course, this is 1 ohm and 1 ohm. And these are all inductors of 1 Henry, 1 Henry, 1 Henry and 1 Henry. Okay, switch has closed. But ideal current source, we open it. Now switch has closed. Now if you observe clearly, now this is the point where, yes, this is the point where I can separate them, yes or no? Yes. L equivalent seen by the R, R equivalent seen by the L. L equivalent seen by the R. Now if you see L equivalent seen by the R, these two are parallel, half Henry and these two are series. So 2.5. 2.5 means 5 by 2 Henry. Yes or no? So L equivalent seen by R is how much? These two are parallel, half, 1 half, and these two are in series. So 2.5, 5 by 2. What is the R equivalent seen by the L? R equivalent seen by the L is 2 ohms. 2 ohms. So simply tau is L by R. Okay, simply tau is L equivalent by R equivalent. L equivalent how much we got? 5 by 2. Okay, this is 5 by 2. By R is also 2, 5 by 4, 1.25 seconds. So answer is what? 1.25 seconds. That means the time constant of the circuit is 1.25 seconds. It will take approximately 5 time constant to reach there. So 1.25 into 5. Okay. So it will take so and so time to reach the final value. That is the intention. Now with the recent, just before we started this PPT, one of my favorite students shared this question, and I am purely writing this question based on the memory. Here data is not clear with the available data what we got so far. I would like to still share the question. Now the question is like this. In one of these 2-port network, he gave Z parameters. Okay, he gave Z parameters as 40, 60, 80 and 100. Okay, yes, 80 and 100. Okay, I would like to write here the same 2-port network with Z parameters as 40, 60, 80, 100. And here Y parameters are given. Y parameters are 5, 2.5, 2.5 and 1 Siemens. So these are Z parameters of this network and these are Y parameters. And the connection is like this. Now carefully identify what is this connection now. If you identify, these two networks are cascaded. Okay, not series please. Series is different. This is a cascade. Output of first port is input to second port is cascaded. Now this has been simplified into a single network. This has been simplified into a simple 2-port network in terms of ABCD. That is what is the data available according to the student. And he is given this in terms of ABCD. Okay, ABCD, or I will write here as, yeah, I would better like this side. Yeah, in terms of T. Okay, let us write this as T. Okay, transmission parameters like some, okay, alpha, beta, okay, gamma and delta. And now he's asking what is the value of beta. See this question, sir. So this is the recent question which came few minutes just before we started the PPT. So he gave one two-port network Z parameters, another two-port network Y parameters, and he combined this into a single network, and from this ABCD parameters is asking beta. So first of all, these two networks are dash connected, cascaded. So in cascaded network, what we can do, ABCD parameters can be multiplied. So what I will do, this Z parameters I will convert into ABCD, this Y parameters also I will convert into ABCD, and then both are cascaded, so I will multiply to get the final ABCD, and from that beta. So if you do this calculation, yes, I am writing the answer here. So interestingly, if you convert Z to ABCD, I am writing directly, this A value here will be Z11 by Z21, which is 0.5, you can check it. B value will be delta Z by Z21, which is minus 10, according to the data given by the student, please. C will be 1 by Z21, okay, which is 1 by 80, that is 0.0125, and D will be Z22 by Z21, this is 1.25. And the second part, as you see the second part, he gave what? Y parameters. Now Y also we should convert in terms of ABCD. So this Y also will convert in terms of ABCD with the available data. So here the ABCD parameters are, A is minus Y22 by Y21, that is minus 2 by 5. B is, yes, minus 1 by Y21, this is also minus 2 by 5. C is delta Y by, minus of delta Y by, what is delta? Delta is nothing but determinant of matrix, okay, Y11, Y22 minus Y12, Y21. So minus delta by Y21, that is nothing but 0.5. And if you see D, okay, minus Y11 by Y21 minus 2, okay. This is the data available. Now finally you converted both this in terms of ABCD, so both are cascaded. So you can multiply them. So if you multiply this ABCD, and the final beta I am getting, okay, this is the final beta, which will be something like, okay, minus 1.5 plus 20, sorry, minus 1 by 5 by 20, okay, that will be the answer. So this is based on the available data, okay, this is based on the available data I am writing here, okay. So this is one of them. Now one more question came, just as I was teaching this, okay, one more question came from one of my student. Now that is on magnetic circuit, okay. So here data is not accurate, but based on the data I am sharing with you, see the question is like this. So he gave a two-port, he gave a magnetic circuit based problem, okay, he gave a magnetic circuit based problem here, okay. Only thing is this data is missing, otherwise I would have gone with the solution, but still I will give you the hint. So here these values are missing, and here also this value is missing, but I got this as 5 Henry and this as 2 Henry, and this is the dots given, okay, and this is 40 microfarad, but this is missing, mutual inductance is missing from my student who gave this, and this resistance are also missing. But he is asking what is the total input impedance, at omega equal to 5000 radians per second. See, this is a standard question which we do in our class. And moreover, I think this should be in millihenry, because if this is really Henry and radians and this is in kilo, that is 5000 kilo, answer would have been very, very high. Practically no transformer will have such a huge impedance. Maybe my interpretation is this is 5 millihenry, 2 millihenry, and maybe this is also some 1 millihenry would have given. Then what I would have converted, now that I am giving the solution. If the data is accurate, I would have converted this into T model. Now in T model, whether it is mutually aiding or mutually opposing, that doesn't mind, because for finding impedance is a passive bilateral property. For finding impedance, nothing is an issue. So what I would have done, I would have converted the transformer of circuit model into T model. But in T model, whether you take aiding or opposing, impedance will not change. So that is a beauty here. So whether he gave dots, but aiding or opposing, impedance will not change, because impedance is passive bilateral. So in that regard, what I would have done is, yes, with the available data, I am just concluding this in 1 minute. So I would have converted this into T model. would have converted this into T model, where if it is mutually aiding, this would be plus M, and this would be L1 minus M, and this is L2 minus M. But how to convert this into impedance? Because reactance plus J omega L na, so this is omega ohms it will come. Omega is 5000, this you have to subtract, and here capacitance is given, and this resistance is unknown for me. If I know all this, then these two are in series, then parallel, then series, that would have been the input impedance. But of course, with accurate data, because definitely it could not be in Henry, because if it is in Henry and omega is in 5000, it would have been in mega and kilo ohms, which is practically incorrect. But with the data available, I am at least giving you the way how the solution can be done, because the T model is the way, and then series, parallel and parallel. Okay. So these are the tentative memory based questions and the solution discussion, the way we can go with the solution for electrical circuits. Okay. I would now wish and request my next faculty member to go with this subject. Okay.
Hello friends, myself Sriram. Coming to the digital electronics, as of now we have received only 2 questions based on the memory of students, okay, right? To obtain the Boolean function f of x comma y equal to something, it has to be implemented by a 4:1 multiplexer. So 4:1 multiplexer P, Q, R, S are the inputs connected to I0, I1, I2, I3 respectively. What should be these values of PQRS? You can see from the options zeros and ones are provided. So first we have to understand this function. Given is a 2 variable function, there are 2 select lines, so that just with the mapping of ones and zero you will get answer. If you find more than 2 variables here, as there are only 2 select lines, then you will have to start with the table. But for this, no need of table, it's a straightforward question. So what will be the function f is equals to 2 variable format, x, y bar, it has given like this, and x bar. So missing variable is y, just you add y plus y bar. So x bar, y bar plus x bar, y. So what are the values? We can write it as sigma m of, what are the min terms? 0, 1, 1, 0, 2, 0, 0, 0 and 0, 1, 1. So that 0, this is 1 and this is 2. These pins should connect it to logic ones. So that P value should be 1, Q value should be 1, R value should be 1 and S is 0. So that 111, 0. A is a correct option. So the expression is given like this and simplified form of a Boolean function. We need to find the simplified form of this Boolean function. Actually we have to expand it, P bar, Q bar into what are the missing terms R and S. We have to add R plus R bar into S plus S bar, but it is a lengthy procedure. But we have discussed in class with one simple method. Let me take a 4 variable K map here. You just think the K-map in reverse order. Okay, from the K-map we can obtain the minterms, but from the minterms we can understand what might be the terms from the function have been loaded into the K-map. This is what the technique we have studied. So PQRS, order is very important, right? So P bar Q bar, P bar Q, PQ and PQ bar. RS, R bar S bar, R bar S, RS, RS bar. What is the function? P bar Q bar. So I'm going to predict the minterms, the respective minterms of the given function. How can you get P bar Q bar? Yes, I can get the P bar Q bar. See, you see, if you have minterms in this row, these minterms. You see this? No common terms here, P bar Q bar. Next, P bar Q S. This is P bar Q. How can you get S here? If there are two minterms here, then we can get S. Next, P Q bar R bar S bar. P Q bar R bar S bar. This is R bar S bar. What next? P Q bar R S bar. P Q bar R S bar. That's it. So now you just focus on the minimization. We are not finding the implicants, okay? So we have to just focus on what we call minimization, so that you just take the groups for quads. Here this is another quad. Sir, can I take one more pair? No need, because we are not calculating implicants here. We are just minimizing the function. So that the minimized answer is, here P bar is common and here S is common. P bar S plus Q bar S bar. Q bar S bar. Q bar S bar plus P bar S. Q bar S bar plus P bar S. B is a correct option. That's all, guys.
Okay, so let's look at analog circuits. So this is a diode problem given. There's a voltage divider with 10 volts here. You are asked to find the current flowing through this diode. I think the voltage here is 3 volts. So this is again 1K, 1K. Okay. So this is the question, and the diodes are considered ideal. Find I or I naught. The diodes are ideal. This is the question. So let's try to find this. So what we will do is we'll replace this using source transformation or Thevenin's equivalent. When you replace by Thevenin's equivalent, you get 0.5K with 5 volts. So here you have a diode, 1K, 1K here. Then this is a diode here with 3 volts. So remember, when is a diode on? A diode is on when the current flowing through the diode is positive. So let's calculate the current here. This is the I naught. If I take this as Ix, this as Iy, then this I naught is going to be directly, I naught is going to be Iy minus Ix. So this is the solution. So what is Iy? I is 3 by 1K, 3 milliampere. And what is Ix here? 5 minus 3 by 1.5K. So you calculate this, it comes around 1.67 milliampere. So this is the solution. So we'll go for the next problem. A BJT biasing circuit is given, VB is 0.7. You're asked to find VC and IC. Now, whatever the technique we have applied, the same technique you apply here again. You break this network, give a Thevenin equivalent here. So it's going to be 100K parallel with 50K in series with some voltage here. This is 12 volt, and voltage division will always give you a fraction of the input voltage. So these resistors are in the ratio of 1:2. So hopefully this should be 8 volt here, and this should be 4 volt. So 4 volt is just the open circuit equivalent. But don't forget, a resistor divider is a resistor divider. It cannot replace a voltage source. So this is going to load an extra resistance of 100K parallel with 50K, which is the R Thevenin. And now with a single loop equation, you can finish this problem. So here you can have 0.7. This is the emitter current. And what is the relationship between the base current and the emitter current if beta is given? You can write this as IE by beta is 100, so 101. So one single KVL will finish the problem. So IE is going to be 4 minus 0.7 by RE. RE is 1K plus 100K parallel 50K divided by 101. So you can calculate this. So that will give you IE. But you are asked to find Q point, which is VC. So one single KVL here again. VCC is 12 volts. So 12 is going to be equal to IC into 2K plus VC plus IE into 1K. And don't forget the relationship between IC and IE. IC is alpha IE. Alpha is 100 by 101 into IE into 2K plus VC plus IC IE into 1K. So please substitute this answer here, you will get VC. So just substitute this answer here. So VC is ready. Okay. So we'll see the last one. There are 3 questions, I think. A differential amplifier is shown in the figure. Assume op amp to be ideal. You're asked to find the CMRR. So what is CMRR directly? CMRR, is it in dB? Yeah, it's in dB, but CMRR is A1 minus A2 by 2 times of A1 plus A2. So what is A1 by superposition? It is V0 by V1 when V2 is 0, and A2 is V0 by V2 when V1 is 0, right? So what is A2? A2 is directly minus RF by R1, minus 101K by 10.5k. This is A2. A1 is the gain, so I'll take this node as Vx. So it's going to be V0 by Vx into Vx by V1, okay? So V0 by Vx is 1 plus 101k by 10.5k, and Vx by Vn again by voltage division 101.5k by 101.5k plus 9.5k. So this will give you A2, A1. So A1 and A2 are there. Please substitute here. You will get CMRR. But what is CMRR in dB finally? CMRR in dB is going to be 20 log CMRR. So I think I've just now calculated it. The CMRR comes to be 40.5. So just substitute these values. It's a simple calculator work. No more calculations, right? Okay, so this is all about analog circuits. Good luck.
Hi students, now I will cover signals and systems few questions. The first question is x of omega is Fourier transform of e power minus t power 4 cos t. The value of d by d omega x of omega at omega equals to 0. You can solve this problem by using multiplication of t in time domain property. What is that property? T into x of t is j dx of omega by d omega. So by using this property you can solve it. Write the Fourier transform expression. J dx of omega by d omega is integration minus infinity to plus infinity t x of t e to the power of minus j omega t dt. He is asking this value at omega equals to 0. Substitute omega equals to 0 in this expression and send j this side. Then dx of omega by d omega at omega equals to 0 equals to, if I send j this side, minus j integration minus infinity to plus infinity t, what is x of t once you observe here, e power minus t power 4 cos t, okay, into omega equals to 0 means e power 0 is 1, so into dt. So what is the value of this expression? You can solve it in a simple way. See here, it is nothing but area under this signal. So cos t, it is a even signal, e power minus t power 4. This is also even signal, but t is a odd signal. So entire is going to be odd. So area under the odd signal is how much? 0. So what is the answer for this question is 0 is the answer. Next question. If energy of x of t is E, then energy of 2 into x of 2t minus 1 is, see here. We know this simple logic, x of t energy is E. What is the energy of x of at? E divided by mod A. What is the energy of A into x of t? Mod A whole square into capital E. By using this logic, you can solve it, and x of t minus b energy is how much? E only. So, based on this logic, tell me x of t minus 1 energy is E only, x of 2t minus 1 energy is E by mod 2 means 2, 2x of 2t minus 1 energy is mod 2 whole square. What is the energy of x of 2t minus 1? E by 2. So the energy is 4 into E by 2, it's going to be 2E. So the energy of the signal is 2E. And the remaining questions will be covered by my colleague Aditya.
So last year also we had good weightage from signals and systems. This year also we have nearly 7 questions from signals and systems. Already 2 questions were covered. Let us look at this interesting problem. So where they're asking what is the Z transform of x of 2n. This is very, very interesting. So let's see how do we solve this. Let us go by the definition. So let's see how to solve this. How do you find Z transform? So Z transform of x of 2n. Let's apply the definition. So the definition says summation n from minus infinity to infinity x of 2n z power minus n. So what we can do is we can go for a substitution like, we can go for a substitution like 2n equal to m. So let's see what happens here. So this gets modified as summation n from, so since we have gone for the substitution, now the limits will be in terms of m. So m will be an even number. So it's a very good question. Let me solve it in a detailed way. So where m is a even number, and then you'll have x of m and then z power minus m by 2. So why it's m by 2? Because 2n is m, so the value of n would be m by 2. Now how do you simplify this? So that's another important step. So m is even. So here comes the excellent new x of m. Just a second. X of m 1 plus minus 1 whole power m whole divided by 2 z power minus m by 2. So this doesn't make any difference because when m is even, this is 1, this is also 1, 1 plus 1 by 2 is anyway 1. But how do you modify this from here onwards? So that's a very interesting thing. So have a look at this. So what we have is summation m is even. So it is x of m, and then you have z power minus m by 2, and then you have one more summation m is even. You have x of m into minus 1 whole power. I can also write minus 1 whole power m as minus 1 whole power minus m, and then this is z power minus m by 2. So if you carefully simplify this, so this is summation m is even. You can write this as x of m, and then you can rewrite this as z power 1 by 2 and then whole power minus m. And then summation m even. So this is also a very critical step where you can miss this. So I'll be very careful here. So this is x of m. I can rewrite this as, so have a look at this. This is minus 1 and then z power 1 by 2 and then whole power minus m. So this is a fantastic move. So you can treat this as x of, and I think I am missing the factor 2. So you can put the factor 2, you can put the factor 2. So this would be x of z power 1 by 2 and then plus. So if you look at this, what is minus 1 into z power 1 by 2? It is minus z whole power, it is minus z power 1 by 2. So this is nothing but x of minus z power 1 by 2 and then you got whole by 2. So this was one of the options. So let's go to the next problem. The remaining problems are simple. So let's see what's the next problem. Now this is a very simple question. It can be solved in multiple ways. So let me look at this. So what they gave is y of t is x of minus t and they're asking what's the nature of y of t convolved with x of t. So what are they asking is, what is y of t convolved with x of t? By the way, what is y of t? It is x of minus t and then convolved with x of t. You can treat this quantity as z of t. So why don't you find what is z of minus t? So z of minus t would be, so wherever there is t, you replace with minus t. So as a result, you get this as x of t convolved with x of minus t. Now if you carefully observe, the convolution obeys commutative law. That means this and this both are same. We have learned that x of t convolved with h of t is exactly same as h of t convolved with x of t. So from this we get that z of t equal to z of minus t. Any signal satisfying this condition would be called an even signal. Therefore, this function that they created is even. So this is one way of solving this. Now those who are aware of autocorrelation function, they can easily solve this in one step, because when you convolve a given signal with the time reversal of that, this is nothing but it is going to give you the autocorrelation function. We all know a property that the autocorrelation function is an even signal. So if you are aware of that, that will also give you the answer. So let's go to the next problem. Now they gave a finite duration signal, because u of t minus 1 in u of t minus 1 minus u of t minus 10 is a finite duration signal. So for a finite duration signal, obviously in the S-plane, the ROC is entire S-plane. So do you have any options saying the ROC is entire S-plane? Obviously it is option A. So let's look at the next problem. So this is already covered. This is also already covered. So this is also already covered. So I think we are left with one more question. So where we did not get the proper data, once we get the data, we will solve that question as well. So as of now, we have solved 6 questions. There is one more question left over. We'll come back with that.
Okay, welcome back students. As expected, there was 4 marks was asked from the electromagnetic theory. Short and sweet, small subject but good weightage. Fine. So let us deal with the questions here which are related to the electromagnetic theory. This is a question. Fine. So given the equation represents the magnetic field strength, the magnetic field intensity is given, R and T are the unit vectors. Fine. So it is a given. So it's asking what is the P value. Fine. Suppose if for the magnetic field, we know that from the one of the Gauss law, divergence of B is equal to 0. It is also mentioned that this magnetic field intensity in the free space. So the B can be represented as mu naught into H. So the mu naught is constant, you can take it out. Divergence of H is equal to 0. Fine. So you should know the divergence formula in the spherical coordinate system. Fine. So let me turn the page here. So what is the divergence formula in the spherical? Divergence of H is equal to 1 by r square sine theta. It is a scaling factor, dou by dou r square sine theta is a one more scaling factor into HR, plus dou by dou theta, r sine theta into h theta, plus dou by dou phi r into h phi, which is equal to 0. Fine. Let me go back here. So here there is r component and theta component. Substitute those values. So divergence of H is equal to 1 divided by r square sine theta, dou by dou r square sine theta into HR component. Let me go back here. HR is P cos theta by r cube. It is P cos theta divided by r cube plus dou by dou theta r sine theta into h phi. What is the h phi? Let me go back. H phi is sine theta by r cube. Fine. So here it is sine theta by r cube. So I'll write this one in a single step. Fine. You can ignore this part. Make this part only equal to 0, which is equal to, what is the differentiation? It is of r square divided by r cube. It is 1 by r. 1 by r differentiation is minus 1 by r square. So P into sine theta cos theta divided by r square plus this part is, in the denominator you will get r square, in the numerator sine square theta. Sine square differentiation is 2 sine theta, successive differentiation is 2 sine theta cos theta. It is 2 sine theta cos theta divided by r square, which is equal to 0. Fine. So bring this part there. So you are going to get the P value is equal to 2. So this was, hopefully it was asked for 2 marks. Fine. So it is directly asking the P value. Let us have one more question. It is related to the superposition principle. Coulomb's law associated with the superposition principle. There are 3 point charges Q, Q, alpha Q located at minus 1 comma 0 comma 0, 1 comma 0 comma 0, 0 comma minus 1 comma 0. The value of alpha for electric field to be 0 at 0 comma 0.5 comma 0. Let us have some simple coordinate systems, so you'll get some idea. Let us consider, here is a coordinate system. This is x-axis, this is y-axis. Where are charges located? Here is a charge. Minus 1 comma 0 comma 0. At this point, Q charge is located. Fine. The other charge is 1 comma 0 comma 0 somewhere here. 1 comma 0 comma 0 plus Q charge is located. The other one is 0 comma minus 1 comma 0 somewhere here. 0 comma minus 1 comma 0, 0. How much charge is located? Alpha Q is located. Is asking a net electric field 0 here, somewhere here, 0 comma 0.5 comma 0. Let me call this as a point P. I'll call this as a charge 1, charge 2 and then charge 3. Fine. So it is said that at point P, the electric field, net electric field must be 0. If that to happen, what must be the alpha value? That is the question. Fine. So we know from the superposition principle, the net electric field at some particular point is equal to the summation of the individual electric fields. So which is equal to 0. So what is the electric field according to the Coulomb's law? Q divided by 4 pi epsilon r square into r cap. This unit vector can be written as vector by its magnitude. So it is Q divided by 4 pi epsilon r cube r vector. And the rest of the story is the algebra, but I will do it for you. Let me turn the page here. So electric field at a point P is equal to, let me go back here. I'll call, what is the force bit, what is the electric field here? It is Q divided by 4 pi epsilon, vector by its magnitude Q. What is the vector? 0 minus of minus 1, it is 1 x cap plus 0.5 minus 0, it is 0.5 y cap divided by magnitude cube. It is 1 plus 0.5 whole square cube plus there is a one more thing between these two things. So it is alpha q divided by 4 pi epsilon into vector by its magnitude cube. What is the vector? 0 minus 0, 0.5 minus of minus 1, it is 1.5. So it is 1.5 I cap divided by magnitude is 1.5 whole cube plus one more thing between these two things. So it is a q divided by 4 pi epsilon vector by its magnitude cube. What is the vector? So it is 0 minus 1, it is minus 1, it is minus 1 x cap, it is 0.5 minus 0, it is 0.5 I cap plus 0.5 I cap divided by square root of 1 plus 0.5 whole square whole cube, which is equal to 0. You can make an observation here. Here x component, you can, that is equal to 0 means resultant is the electric field. So if it is 0 means it is a null vector. 0 in the sense, the 0 in terms of vector means it is a null vector. So you can make all the x component equal to 0. All the y component is equal to 0. If I make this is the x component, here is the x component. In the x component, you do not find any x value, any alpha value. But the question here is to find out the alpha value. So that you can obtain by making the y components on the both sides equal to 0. Fine. So let us make the y components is equal to 0 on the both sides. What is the y component here? It is q divided by 4 pi epsilon 0.5 divided by square root of 1 plus 0.5 whole square whole cube plus here is a y component. So which is alpha into q divided by 4 pi epsilon into y cap divided by, just remove this, it is 1 divided by 0.5 square and there is a y component. So plus q divided by 4 pi epsilon 0.5 divided by square root of 1 plus 0.5 whole square whole cube. Fine. So you can make this one is equal to, here it is 0.1, here it is 0.5 it is a 1, and you can just remove this q on both sides, and 1 by 4 pi epsilon is also constant, remove on both sides. It is 1 divided by square root of 1 plus 0.5 whole square plus alpha divided by 1.5 whole square, which is equal to 0. So the alpha value, you can check it out, which is equal to minus, this will turn out to be minus 1.5 whole square. This approximately you will get it as 1.4. So you can check out, this one will approximately equal to minus 1.61. So directly, it is the idea here is a superposition principle, rest of the thing is the algebra. Fine. Okay. So these are all the questions which are related to the electromagnetic fields. Hope you people have done well. I'll hand over the session to the other colleague member. Thank you. Good luck.
In control system, ask the 6 questions. The first question is, it is related to the block diagram. Simply ask the transfer function. So by using the Mason's gain formula, so C of S divided by R of S equal to, so here there is only one forward path. The forward path gain is minus G of S divided by 1. There are the 2 loops. This is loop 1, this is loop 2. So the loop 1 is 1, opposite sign of loop gain is minus G of S. Again opposite sign of second loop, here minus minus become the plus, opposite side means minus G of S. So the answer is minus G of S divided by 1 minus 2 G of S. So answer B. Next. So this belongs to the root locus, angle of departure he asked it. You need to find the angle of departure at the location of -1 plus J2. So I'll write the transfer function G of S equal to K into S square minus 2S plus 2 divided by S square plus 2S plus 5 at S equal to -1 plus J2. You need to find just angle of departure. What is the formula for angle of departure? Pi d equal to 180 plus angle GH. Here unity feedback given G of S at S equal to -1 plus J2 we need to find. So now first find angle G of S at S equal to -1 plus J2. So I can write it as angle of K, angle of S -1 plus J1, angle of S -1 minus J1 divided by angle of S plus 1 minus J2. So then angle of S plus 1 plus J2. Now substitute S equal to -1 plus J2. So angle of K, angle of -1 plus J2 plus -1 plus J2 so -1 plus J2, here -1 plus J1. S replaced by -1 plus J2. So -1 plus J2 -1 minus J1 divided by angle of -1 plus J2, J2 plus 1 minus J2, angle of -1 plus J2 plus 1 plus J2. So find the angles here, -1 plus 1 J2. Here I think it is plus J2. 1 minute. -1 plus J2 minus 1 plus J2. So these two cancelled, and then here -1 this is cancelled, and then if you write this you will get angle of K, angle of here -2 plus J3, angle of here -2 plus J1 divided by angle of 0, angle of J4. Then find these angles, you will get 187.12 degrees you will get. Then if you find pi d, then 180 plus angle GH, 180 plus 187.12 degrees. But in the question mentioned that the range is given 0 to 360 degrees. So we can write this equal to 367.12 degrees. So if we remove 360 degrees, I can write 7.12 degrees. The answer is 7.12 degrees. Next. So here consider a cascaded system shown in figure, and neglecting the faster component of a transient response. Which one of the following of the, he is asking simply first order pole. So, it is asking the approximated system, very clearly mentioned, only approximation such that steady state value of unit step response of the original and approximation system is same as. So, what is the transfer function here if you write C by R, if you write it here, what we are getting? S plus 40 divided by S plus 1 into S plus 20. It belongs to the insignificant pole concept. So, we can neglect the insignificant pole here. Not only that, you observe the 4 options, he neglected even 0 also. So, as we know that we can add any pole or any 0, or we can neglect any pole, any 0, but the system gain should not be changed. If you find here system gain, what is the system gain you are getting? So, to find system gain, the given function must be converted into time constant form, 1 plus S by 40 divided by here 1 plus S as it is, here 20 take it common, 1 plus S by 20. So, here we can neglect this insignificant pole, we can neglect this 0 because we consider only poles. Then if you solve this, 40 by 20 means 2. So, that means 2 by S plus 1 is the answer. So, the approximate system is what? 2 by S plus 1. So, answer A is correct. Next, here you taken as 2 systems and given omega n is 3 and theta 60, and here omega n 1 theta 70 given, and is asking a question related to the what? Settling time. As you know the formula for settling time, default settling time is what? 2%. That means what is the answer? 4 by zeta omega n. So, if I take it system 1, so for system 1 omega n directly given, omega n given 3 directly. Zeta is equal to cos theta, theta is given, theta is how much given? 60 degrees given. So, this is 0.5, cos 60 0.5. That means for system 1, settling time you find. So, what is the formula for settling time? 4 by zeta omega n. 4 by zeta is 0.5 into omega n 3. If solve it, you will get 2.66 seconds you will get. Similarly, find for system 2. Find for system 2, TS2 if you calculate, you will get 11.69 you will get. Similarly, if you calculate 11.69 you will get. So, 11.69 you will get. That means TS2 is greater than what? TS1. So, settling time system 2 is more than what? Settling time system 1. Next. That's all. Right, one more question also is there. I will read the question. He given a stable closed loop control system and he is telling that the asymptotic magnitude plot is related to the border plot, magnitude in dB. He given that the asymptotic border plot moving with the slope of minus 20 dB for decade, and it is crossing the 0 dB line at a frequency of 10, and simply ask the steady state error to the what? Unit ramp input he asked. Unit ramp input. This is the question asked. We solved these questions even in the class. Unit ramp input. Simply what is G of S? What is the transfer function? Tell simply K by S. So, K is nothing but whenever it moves in a slope of minus 20 n, intersect at 0 dB line at a frequency of omega n, that will become a K. So, that means 10 by S. So, by default we will assume it is a unity feedback. So, H of S is 1. What is the steady state error formula? Simply A by KV. A is nothing but 1. KV is nothing but what? 10 here. So, that means you will get the answer is 0.1. So, that's all. Next my colleague will continue.
now we are going to discuss the questions from subject power electronics. So total 6 questions they asked and the weightage was 9 marks, right? So this is the first question, very simple. This question is from chapter number 1, power semiconductor devices, right? I hope you might have answered this question. If the following switching devices have similar power ratings, which of them is the faster? Yeah, come on, tell me which of them is faster. We know till now we are having the fastest device is a power MOSFET, alright? So option D is the correct option. Next, a single phase time based AC voltage controller, that is AC to AC converter, feeds RL load. The input AC supply is 230 volt 50 hertz. The values of resistor and inductor are 10 ohm and 18.37 millihenry respectively. Load is RL. The minimum triggering angle of the triac to obtain the controlled output voltage. Instead of this controller, there should be the controlled output voltage. Okay. So tell me, if the load is RL load, then what is the range of firing angle for getting the controlled output? For getting controlled output, the range of firing angle is from phi less than or equal to alpha less than how much? 180 degree, na? Right? So what is the minimum value of firing angle? Minimum value of firing angle is nothing but phi. And what is phi? So I can write here alpha mean is equal to phi, and phi is equal to tan inverse of omega L by R. Alright? So it is equal to tan inverse of, put the values, omega is 2 pi into 50 into L is 18.37 millihenry into 10 to the power minus 3, right, divided by R is 10 ohm. Yes. If you simplify it, you will be getting it as a 30 degree. So my alpha mean is a 30 degree. So correct option is option A, right? Simple question they have asked. This question is from AC voltage controller. Next, in the DC to DC converter shown in the figure, the current through the inductor is continuous. So conduction is a continuous here. The switching frequency is 500 hertz. The voltage V0 across the load is assumed to be constant and ripple free, right? So load voltage is a constant. The peak value of the inductor current in ampere is, so he is asking the Imax, right? So we know in DC to DC converter, Imax is equal to what? IL average plus delta IL by 2, na? Delta IL by 2. So for finding Imax, we want IL average and delta IL. Okay, so let us first find the duty cycle here. Here supply voltage is 20 volt, output voltage is a 40 volt. And which converter is this? This is your boost converter, na? Inductor is connected at the source side. So here I can write for boost converter V0 is equal to Vs upon 1 minus D. So V0 is a 40 volt, which is equal to Vs. Vs is a 20 volt upon 1 minus duty cycle. Simplify this, from after simplification we will be getting a D equal to 0.5, right? So this is my duty cycle. Now output voltage given is a 40 volt and load resistor is a 10 ohm. From this I can find a I0, right? So I0 average is equal to V0, or you can write it as V0 average by R. My V0 is a 40 volt, so 40 upon R is a 10, so it is a 4 ampere, right? 40 by 10 is a 4 ampere. This is a I0 average. Further, for the boost converter, what is the expression for IL average in terms of I0 average? Yes, IL average is a I0 average upon 1 minus D, ampere second balance equation result, alright? So I0 average is a 4 upon it is 1 minus duty cycle is 0.5. So it is equal to 8 ampere, alright, 8 ampere. So IL average we have calculated. Now we need to find delta IL, na? Right? So for finding delta IL, simply write during t equal to 0 to dt, when switch is in a on state, what is the voltage across inductor? VL is equal to Vs, na? Right? So during t equal to 0 to dt, my VL value is equal to Vs. But VL means what? L into DIL by dt. DIL means delta IL. dt is nothing but a T on.
that is d into t is equal to Vs. From this I can get delta IL. Therefore, delta IL equal to Vs into dt divided by L, or you can write it as Vs into d by FL. Okay, now put the values. Supply voltage is a 20 volt, duty cycle is 0.5 upon frequency they have given it is a 500, and value of inductor value is a 2 millihenry, that is 2 into 10 to the power minus 3, right? Simplify this. After simplification you will be getting it as equal to 10 ampere. So delta IL. Now from this I can write Imax, which is equal to IL average plus delta IL by 2. IL average is 8, delta IL is 10, so 10 by 2. So it is equal to 8 plus 5, that is a 13 ampere, right? So my Imax is equal to 13 ampere. Next question. A forced commutated thyristerized step down chopper is shown below. So this is the circuit diagram they have given, right? Next, neglect the on state drop across the power device. Assume that the capacitor is initially charged to the 50 volt as shown in the figure. The load current can be assumed to be constant at 10 ampere. So load current is a constant he has given, right? Initially the T main, that is a main thyristor, this is a thyristor, this is not a diode, main thyristor is on and TA is a off, auxiliary thyristor is in off state. The turn off time available to main thyristor in microsecond when TA triggered is. Okay, so my dear friends, if you check this circuit, here they are saying initially my thyristor is in a conduction mode, main thyristor, and this capacitor is charged to which voltage? Supply voltage, that is a 50 volt, okay, with a polarity plus here minus here, this voltage is a 50 volt he has given. Now at t equal to 0, when I apply the gate pulse to the auxiliary thyristor, what will happen? As soon as my auxiliary thyristor turns on, this supply voltage will appear as a reverse voltage for main thyristor. So therefore my main thyristor will immediately turn off. So here main thyristor is turning off due to the reverse voltage. So that's why this is your voltage commutated chopper circuit na. And recall, in voltage commutated chopper circuit, what is the circuit turn off time for main thyristor? We have written expression C into Vs by I0. Now simply put values. C is a 10 microfarad, Vs is a 50 volt, and I0 is a 10 ampere, right? So this will get cancelled out, so it is a 50 microsecond, right? Same voltage commutated chopper circuit they have asked the question. Next question, yeah. So my dear friend, these are the questions from power electronics. Next my colleague will continue with this subject, right?
So earlier we solved 5 questions from signals. We got 2 more questions from signals and systems. So one of the question was like this. They gave a input-output relation in the following way. So it's e power minus t integral minus infinity to t e power tau x of tau d tau. And they're asking about the linearity, time invariance, whether the system is causal or not. Now look at this integration. So we all know you would have solved many problems. So if you have a integration symbol there or integration like that, it is always a linear system. So if you want, you can check it. So you can check the additivity and homogeneity principles. It is definitely a linear system. Because you would have solved many problems, so I'm not going to solve in detail. Now what about the system, whether it is causal or not? if you carefully read this, what it says. If you want to find the response at this instant, then how do you get that? It is, you need to integrate from minus infinity to that instant. So this is clearly like you need the present and the past information about this input. So when you need the present and the past information about the input, clearly that's a causal system. So there is no doubt that it is definitely a causal system. Now comes the time invariance. You would have solved many problems related to time invariance. So how do you solve it? So I'll quickly solve two things here. So what we usually do is, we will find the response due to delayed input. So what is the response due to delayed input? So it's like this. It's e power minus t integral minus infinity to t. It's e power tau x of tau minus t naught and then d tau. So this is the response due to delayed input. We also find the delayed output response, where we replace t with t minus t naught. So in this given expression, wherever there is t, you can replace with t minus t naught. So you get e power minus of t minus t naught and then integral minus infinity to, we have t, so this is t minus t naught, you have e power tau and then you have got x of tau, no need to replace here, and then d tau. Now what you need to do is, you need to compare these two things. So through substitution you can prove that both of them are same. So let me consider this particular expression and I'll prove that this is equal to this. So let's go to the next page. So what is that expression? So what's the output? What is the output due to the delayed input? So it was like this. It's e power minus t integral minus infinity to t and then you had e power tau x of tau minus t naught and then d tau. With a simple substitution like this, that is tau minus t naught, let this be z, you differentiate, you get d tau equal to dz. So from this we can say that tau is z plus t naught and the limits will also change. So the lower limit, if you want, you substitute this here. So the lower limit would be minus infinity. If you want the upper limit, substitute this here, the upper limit would be t minus t naught. So this expression modifies like this. So it's e power minus t, the limits, the new limits are minus infinity to t minus t naught, and then wherever there is tau, you need to put e power, wherever there is tau, you have to put z plus t naught. So this is e power z, you can split as e power t naught as well, and then x of z and then dz. This e power t naught can be brought out of the integral when you club this with this, and when you compare with your previous expression, it exactly matches. For example, why don't you multiply this minus here? So it's minus into minus is plus e power t naught. So here also you have the same expression e power t naught. So in all other aspects both are same, meaning by it is a time invariant system. So what's the final answer for this? It's a time invariant system. So linear causal time invariance, a very beautiful problem. So we have got one more question from signals and systems, and that was like this. They give a question like this, where the output is given as y1 of n or some transformation on the input. So x of 0 plus x of 1 plus so on plus x of n. So they are asking whether this is a stable system or not. You can rewrite this as summation k from 0 to n x of k. So in the place of x of k, if you substitute u of n, okay, then you get a ramp sequence. Okay, we don't need to exactly see what is that ramp expression, but if you can imagine that the ramp sequence increases as n increases. Therefore, this is not a stable system, it's an unstable system. So it's an unstable system, and most of you already know, by the time I write the accumulation, by the time I write the summation expression, by that itself you can say that it's an unstable system. So this was one of the question. There is another part in this, so let us look at that. This is very simple, and the second part is even interesting. So let us look at that second part, where the input-output relations were given like this. So it's x of 0 plus x of 1 into 1 by 2 power 1 plus x of 2 into 1 by 2 power 2 plus so on plus x of n 1 by 2 power n. So if a system is described by this input-output relation, is this system a stable system or not? So how do you judge this? So what I usually do is, let us apply. So we usually apply a bounded input. So bounded input means its maximum value is obviously a finite number. So in the place of all these input values, let me substitute the maximum value. So we are substituting the maximum value. So let the maximum value of x of n, the maximum value of x of m, let this be m. Now you can rewrite y2 of n as, since m is common, what is left is 1 plus 1 by 2 power 1 plus 1 by 2 power 2 plus so on plus 1 by 2 power n. Clearly this is sum of terms in geometric progression. Even if n tends to infinity, this quantity is a finite number, hence the overall output is a finite number, meaning by this is a stable system. So the first system described by the input-output relations is unstable, the second one is stable. So it is not BIBO, this is definitely BIBO. So these are the 7 questions that were asked from signals and systems. So next, mathematics faculty Ravindra Reddy sir will continue.
Now let us start the questions on mathematics part. I got some questions from the students. So let us go to the first problem. Now it is a question from the complex variable topic. In every option, one function is given and we are asked to choose the function which is analytic. So let us start with the one by one option. First we start the first option. Now in the first option, the function is given that quadratic polynomial. Already we know that every polynomial is analytic everywhere. So this function is analytic because of the polynomial function. Next we go to the second option, f of z equal to imaginary part of z. Here if you write the function u plus iv equal to f of z equal to imaginary part of z means just y, or we write this as 0 into I plus y. This is a real part, this is the imaginary part, or we can have the y plus 0i. This is v, this is u1. Now we can check the CR equations. Both CR equations satisfy, we can check the continuity condition, then we can say that function is analytic or not. Let us verify the CR equations for this. Here ux equal to 0 and vy is also 0, and these two are same. The first CR equation is satisfied. Now let us check the second CR equation, vx equal to minus uy. But from this v with respect to x is 0, and from this u with respect to y is 1 and it equal to minus 1, and these two are not same. The second CR equation is not satisfied, or one of the CR equations is not satisfied for the function, so it is not analytic. Next let us go to the option C. Directly we can say the function is not analytic because we know that mod z is not analytic at any point, e power mod z is also not analytic, so directly we can eliminate this. And again this is the f of z equal to, just imaginary part is given for the function, option D, u plus iv equal to f of z equal to I into or j. Instead of j I am taking the I, real part of z is x, or we write this as 0 plus I into x, this is u real part, this is imaginary part v, and we check the CR equation satisfy or not. ux equal to vy, ux is 0, vy is 0, the first equation satisfied. Let us go to the second equation, Vx equal to minus uy or not. Vx is 1. Next, uy is 0. Again, it is not satisfied. So the function is not analytic. So out of all these, only the first function is analytic. Because of the standard function, it is everywhere analytic. Now let us go to the next problem. If A square equal to the 2 by 2 matrix square, then the sum of the eigenvalues of A square. A square means this is, let us consider this as A. For this A, if you know the eigenvalues, we can find the eigenvalues of A square on. Let us find the eigenvalues of this matrix A. Now write the characteristic equation, lambda square minus into lambda, but here the quotient of lambda is the trace of this matrix 1 plus 4, that is 5 into lambda plus determinant. Determinant is 4 minus 6 minus 2. It's a quadratic equation, or it is a characteristic equation of this matrix A. It is a quadratic equation, and this is the characteristic equation of this matrix A only. Now we solve it for lambda. Directly by factorization method not possible to find the roots, so we go for general formula of quadratic equation. Lambda equal to minus b plus or minus under root of b square minus 4ac by 2a. Minus minus here plus or minus under root of b square is 25 and 4ac is 8 plus 8 divided by 2, and this is equal to 5 plus or minus under root of 33 divided by 2. Now we have the two eigenvalues for 2 by 2 matrix. One is 5 plus root 33 by 2, other one is 5 minus root 33 by 2 only. Suppose A has eigenvalue lambda, then A square will have an eigenvalue lambda square. If lambda is the eigenvalue of matrix A, then lambda square is the eigenvalue of A square only. So already we know the lambda value, but here we require the sum of the eigenvalues of A square only. Because sum of the eigenvalues of A square means, here if it is lambda 1 equal to 5 plus root 33 by 2, and lambda 2 equal to 5 minus root 33 by 2 only. And for this A square, sum of the eigenvalues is same as the lambda 1 square plus lambda 2 square. Eigenvalues, sum of the eigenvalues of A square. If lambda 1, lambda 2 are eigenvalues of matrix A, then for A square eigenvalues are the particular value is lambda 1 square, lambda 2 square only. So just we square and add these two only. Square of this is 25 plus 33 plus 2 into 5, that is 10 root 33 by 4. Next, plus again square of this, that is 25 plus 33 minus 10 root 33 by 4. These two get cancelled, and 25 plus 33, that is 358. Next, plus 2 times this one, 3 plus 2, 5. And 2 times, so this is equal to it is a value. This is the sum of the squares of the eigenvalues or sum of the eigenvalues of this A square matrix. So the answer is 29 now. Now let us go to the next problem. The directional derivative of the function in the direction of this vector at the point. Now this is the function, scalar function. Let us suppose this is phi, and this is a vector, direction vector. It is a point P on. Now first we need to find the gradient of this function, that is a vector. Del phi equal to this function with respect to x, derivative, partial derivative, into I bar. It is a function in terms of x and y. It is free from x. It is in terms x. So we have to find the derivative of these two terms. 2 into log derivative is 1 by xy. Again xy derivative is y. These two get cancelled. Plus it is 0. Plus here 3 by xz. And again xyz derivative is z. Z get cancelled into I bar. Plus again j bar into with respect to y. These two terms are contained in variable y. It is free from variable x. So it is 0. Then for these two, we find the derivative. 2 divided by xy. Again, xy derivative with respect to y is just x. These two get cancelled. Plus, again, its derivative with respect to y is 1 by yz. And again, inner function derivative with respect to y is z. These two get cancelled into j bar plus. Again, k bar into dou phi by dou z with respect to z. This is free from z. These two are containing the variable z. So we have to differentiate these two partially with respect to z. Log y, that is 1 by yz, and again with respect to z, y get cancelled plus. Again this with respect to z is 3 by xz, with respect to z again it is x cancel into k bar. So finally this is the del phi, but we require del phi at a particular point. X equal to 1, y equal to 1, z equal to 1, 2 plus 3, 5 into I bar plus 2 plus 1, 3 into j bar plus 1 plus 3, 4 k bar. This is the gradient of a vector function, but we require the directional derivative of this function in the direction of this. So directional derivative in the direction of this vector a bar is given by del phi at a point P dot a bar by modulus of a bar. Dot product of these two on. Now it is a vector del phi at a particular point, and it is a bar vector. The dot product of these two is 5 into 2, 10 plus 3 into 1, 3 plus 4 into 2, 8 divided by the unit vector of this is under root of 2 square plus 1 square plus 2 square. 4 plus 4, 1, 9, root of 9 is 3, and here 21 divided by 3, this is 7. It is the value of the directional derivative of the function at a particular point in the direction of this vector. Now let us go to the next problem. Which of the following matrix is invertible? First of all, invertible means inverse exists. For any square matrix, determinant is not equal to 0, the matrix is invertible. That is inverse exists, invertible matrix. So to check the matrix is invertible or not, it is enough to check just the determinant of the matrix only. For any one of the option, determinant is not equal to 0, such a matrix is invertible only. So we check determinant is 0, not equal to 0, determinant is equal to 0, not equal to 0, determinant is equal to 0, not equal to 0, like this only. So for the first option, determinant is 1 into 16 minus 4 minus 4 into, or we can expand along this, plus 0 plus again 1 into 8 minus 32, and here it is 12, and again it is sum of all this is not equal to 0, so determinant is not equal to 0. This matrix is invertible matrix. Option A is correct. And here if you observe all the elements, the first and last rows are proportional. When two rows are proportional in a determinant is always 0. So this is wrong. Because of singular, inverse does not exist, not invertible. Again here, in this option also, if you observe the first and last columns, these two are multiples. Because of the same or proportional, determinant is always 0. The matrix is singular. Because singular, the matrix is not invertible matrix. So it is also wrong. Next, again, we find the determinant of this matrix. If determinant is not equal to 0, then it is invertible. Determinant is 0, not invertible only. So just we check determinant is 0, not equal to 0 only. Again, we expand along the first column. 1 into 16 minus 2 plus 0 into something 0 plus 0.5 or 1 by 2 into 8 minus 32. Again, sum of all this is also not equal to, so this is 16, it is also 0. So this matrix is also singular. Singular means inverse does not exist, so not invertible. This is also wrong because we are asked to choose only the matrix which is invertible. It's indirectly non-singular only. So out of all these options, only one of the option is non-singular. So it is correct answer. With this, the problems on So with this, the problems on mathematics are completed.
Hi everyone, now I am going to discuss the questions from measurements as well as machine subject. In the measurement subject, according to the memory based, we have got one question like, it looks like MXQ model. The question is, which of the following is or correct? Which of the following is or correct for a CT? Means current transformer. This is the question from instrument transformer. According to the data we received, the options are like, say which of the following are correct for CT? CT means current transformer. Now, for this, the answer here is current transformer must be always connected in series in the line. So therefore, this is the correct answer. Series in the circuit, it is one correct answer. And so for CT, secondary circuit, secondary should not be opened. So therefore, secondary never be opened. Secondary never be opened. So these two are the correct answers. So it might be MSQ model. So these two are correct. Other two options anyway wrong for this. And one more question from the electrical measurements. This is 2 wattmeter method question. The approximate data we received is, it is a delta connected load, right? two loads are given here. Two loads are given like this. And here anyway, three-phase supply is given. Line voltage given is 400 volt. This is given as R, this is Y, and this is B. The supply is connected here. In this line, they have connected one wattmeter, right? Current coil and potential coil like this. This is CC and this is PC. According to the data, I am treating this as W1, and one more wattmeter is connected here. This is potential coil. This is potential coil, and current coil is connected here. In this, the current coil is connected like this. Okay, now the question is, in this entire way, this is a PC and this is CC, this is a W1. Okay, now the question is, what is the value of W1 minus W2? Nothing but the difference between the readings of these two. In the class also we have taken so many questions related to this model. Whatever may be the connection of wattmeter in the given circuit, what is the procedure I told? W1 is equal to voltage across potential coil, current through current coil, and cosine of the angle between these two, VPC and ICC. VPC and ICC. And in the same way, for W2 also, voltage across potential coil, current through current coil, cos of angle between VPC and ICC. If you are able to write this equation, it is a very, very simple numerical. The point is, if you see this first wattmeter, according to the data we receive, potential coil is between R and B. So therefore, what you have to write here? VRB. And current coil is connected in R. So therefore, IR. We need to take the angle between VRB and IR. And second one, where is the potential coil? B and Y. So therefore, VYB, and current coil is anyway in Y phase. So therefore, IY, cos of angle between these two. And in this question, some other data is also given, that is, sequence to be considered is RYB, and here some load is given, some values are given, here also some values. I am taking Z1 and Z2 for example. Okay. Now, according to the given data, RYB sequence, if you are taking the supply VRY, VYB and VBR, because RYB is a sequence. And what is VRY? 400 at an angle 0, because it is a reference. Here also 400 at an angle minus 120, 400 at an angle minus 240. Now, based on this data, VBR is there, we need to get VRB, get it. What is IR? Sir, IR is current through this. This current is sum of this current I1 as well as I2. How do you get I1? Voltage by impedance, Z1 values not exactly available right now. So substitute this. V by Z1, I1 will be there. V by Z2, I2 will be there. So therefore, I1 plus I2 is current through this. If you substitute these two, an angle will be available. And after getting these two values, W total, according to the given data, W1 minus W2 you find out. So this is the procedure. So whatever the value you are getting, so that is the final answer. Around 600 change may be there, according to the values available. These are the questions from measurements. Now I am continuing the questions from the electrical machines part. Let us see the question here. This is the question from induction motor, right? A 50 Hz 6-pole induction motor is there. Runs at 960 RPM. So therefore, this is NR. This is the number of poles. This is the frequency. In this question, stator copper losses, stator core losses, rotational losses are neglected. Almost all losses are neglected except rotor copper losses. In this entire question, rotor copper losses are not neglected. he is asking what is the percentage efficiency. Very simple. If all losses, what is it? Stator copper loss and stator iron loss, and then what is it? Rotational losses are neglected. These are neglected. And according to theory, you know, rotor iron losses anyway neglected. Rotor iron loss. Generally, by the concept also we can neglect it, survive. Rotor iron loss depends on rotor current frequency, which is very, very small, neglected. So if you are removing all these losses, which loss is available now? Only rotor copper loss is available, right? So in this entire thing, in my class also told you, right? If all losses are neglected except this, so what is the efficiency of the machine? What is the efficiency of the machine? 1 minus S. 1 minus S. Now, from the given data, from this data, what is NS? 120 F by P. You will be getting 1000 RPM. You will be getting 1000 RPM. 1000 RPM and NR is 960 RPM. Therefore, slip is how much? NS minus NR by NS. What is the value? 0.04. Now substitute this. 1 minus 0.04. You will be getting, what is it? Or in 200 percentage means simply 0.96. Nothing but the efficiency is 96%. If you are able to remember this formula, the thing will be very, very simple. Right. Next question. So this is the question from again induction motor, right? Slip ring induction motor. Question looks like lengthy, but if you remember the basic formula, solution is very simple. Stator resistance is given, stator reactance is given, rotor resistance referred to. He has given clearly rotor resistance referred to stator. That's why he has given XR dash, RR dash. These are the rotor values, but when referred to the stator. And the per phase stator rotor effective turns ratio, 3:1 turns ratio is given. And the rotor winding is also star connected. So both are star connected. Right? The magnetizing reactance and core of the motor can be neglected. So based on this entire thing, what he is asking, sir, in order to get how much resistance must be connected externally. Externally, how much resistance is connected? For this, one formula is there here. The two, at the time of starting, he is asking at which value? Maximum torque at starting. Sir, under starting conditions, what is the slip value? The starting condition means motor it's not yet started, therefore slip is equal to 1. So under this entire condition, what is the slip value? The slip value formula is R2 dash plus RE dash by root of R1 square plus X1 plus X2 dash whole square. So this is the value and this should be equal to 1 because he is asking torque must be maximum at starting. So starting means S equal to 1. If you substitute all these values, you will be getting the value as RE is equal to or RE dash is equal to, you will be getting 2.5. Whatever the values they have given, substitute here, you will be getting this value. And finally, R external is equal to 2.5 by, what is the value? 3:1. So therefore K square notation. So therefore here by 9 will be there. You will be getting 0.277 is the answer. This much of resistance must be connected externally to get the corresponding condition. And one more question here is, it is related to DC shunt motor. In this, the data is beautifully given. No load data is given and he is asking full load data. No load current is given and here asking full load value. What is the data here? 5 kilowatt 220 volt is the rated value. No load current, drawing a no load current of 3 ampere with an armature resistance including the brush drop. So no need to worry about the brush drop here. 0.5 ohm combination is given. The field current is maintained at 1 ampere and the core and the rotational loss are constant. Now, always if these type of questions are given, try to draw the figure, then the solution will be very simple. Here, what is the current drawn under no load means IL naught I am writing. This IL naught is how much? 3 amperes. This is the current he has given, 3 amperes. And what is the field current they have given? The field current maintained as 1 ampere. So therefore, field current it is a shunt, no. So therefore, 1 ampere. Under this condition, what is the value of IA? That IA, or I am writing IA naught. What is IA naught? IL naught minus ISS. So therefore, 2 amperes. Okay, now, sir, no load armature current is there, but he is asking which current? The load at maximum efficiency. Then the load actually is load current. Load current at maximum efficiency. Under loading conditions, we need to get the current, and that too under maximum efficiency condition. Now, so for this, how to proceed here? How to proceed? Sir, from this, what is the constant losses? Constant losses is equal to input minus what is it? Variable loss, IA naught square RA. What is the input value they have given? 220 into 3, because 220 is the voltage, current is the input 3, and what is IA naught? 2 square, RA is given as 0.5. If you simplify this, you will be getting 658 watts. Sir, either it may be no load condition or loaded condition. Loss are always constant. So therefore, these are no load as well as load losses. Okay. Sir, under no load condition, these are the loss. Under full load condition, also same loss. Therefore, what we can write now? Sir, maximum efficiency. What is the maximum efficiency condition? Variable loss is equal to constant loss. Variable loss equal to constant. But which loss we have to consider? Load losses. So therefore, I load, otherwise I am writing simply IA load square RA is equal to constant loss is how much? 658. So therefore, IA, for idea purpose I am writing full load, root of 658 by 0.5. You will be getting approximately 36.276 amperes IAFL. But what he is asking, just check it. The current from the drawing measure. So nothing but the total current IL is equal to 36 plus 36.276 plus what is the shunt field current? 1 ampere. Therefore, the final answer is 37.276 amperes. Nothing but he has given the no load values and he is asking the full load value of current. And one more question. This is the question from synchronous generator. It looks somewhat lengthy, calculation part is also there, but if you follow the procedure, answer is very simple. Here 11 kV is given, 10 MVA synchronous generator is given. Inductive load of power factor √3/2 via lossless line with per phase inductive reactance. Very, very important. Lossless line, so simply R is given as 0. And the per phase synchronous reactance of generator 30 ohm with negligible resistance. If the generator, here also negligible armature resistance, RA is 0. If the generator is producing the rated current at rated voltage, then the power factor at the terminal of the generator is. Right? So for this, what is the procedure? Let us see here. And so here, what can be the value of IA rated? IA rated here is, what is the power they have given? 10 MVA and here 11 kV. So therefore, if you are writing that 10 into 10 power 6 and √3 into 11 into 10 cube, because √3 VL IL, from that I am finding the current. If you simplify this, you will be getting 524.86. 524.86. After that, we know we have one formula. 11 kV is there, no, this is the line voltage. So therefore, I am converting that into phase equal to, what is the formula? Root of Vt cos phi Ia RA whole square plus Vt sin phi Ia XS whole square But in this, RA is not given, so therefore we can write directly V cos phi plus IA RA, not given, no, so directly, right? And then V sin phi into, or V sin phi plus IA XS whole square. If you substitute all the values, you will be getting V value from this. Substitute cos phi value and then sin phi XS value, you will be getting approximately 4618.121 volt. So this is the V value. After that, we know one formula. Tan psi is equal to, what is the formula? V sin 30, because he has given this root 3 by 2. Root 3 by 2 means simply phi is equal to 30. So therefore, I am substituting that V sin 30 plus IA XS is given as phi divided by V and then cos 30, V cos 30. So from this, you will be getting, V substitute here, you will be getting psi value as 50.913, 50.913. What he is asking here? Power factor at the terminal of the generator. So therefore, simply, right, psi value is there, therefore, power factor means cos of this angle. So therefore, cos of 50.913, if you are substituting this, you will be getting 0.63. Of course, it is an inductive lagging. So answer here is 0.63 lagging. So these are the questions from measurements as well as mission subject. Next question will be continued by the faculty.
Hello everybody. So welcome back, and the next subject is power systems. Now we'll take the questions on power systems. Right students, this is the first question here. So the first question is the mechanical input PS is equivalent to 0.5 Pmax given here, and it is a 2-bus power system network, and where the electrical power PE is equivalent to Pmax sin delta, and fault occurs on line 2. So given here, this is line 1 and this is line 2, and the fault is occurring on line 2. So, and after the fault, the electrical power that is delivered is less than that of 0.5 times of Pmax. So, initially PS is given, PS is equivalent to 0.5 Pmax, and the electrical power is given, PE is equivalent to Pmax sin delta. And from these two, we can write that PS initially, PS is equivalent to PE1, and PS is given 0.5 Pmax, and the value of PE1 is given Pmax sin delta. Pmax sin delta not we can take. Why? Because it is initially. Therefore, from this one Pmax will be cancelled. You can calculate the value of delta naught is equivalent to 30 degrees. Clear, right? That is the initial load angle or initial torque angle we are having here. And after that, the fault is occurring on line 2, and after the fault PE2 is less than that of 0.5 Pmax, and PE3 is given, it is Pmax divided by root 2 sin delta. So, given PE3 is nothing but Pmax divided by root 2 into sin delta. From this equation, we can write this is the maximum power after the fault. Therefore, Pmax 3 is equivalent to Pmax divided by root 2. Therefore, we are having Pmax 1 in terms of Pmax, and we are having Pmax 3 in terms of Pmax, but we don't have Pmax 2 in terms of Pmax. Clear, right? And what they are asking, fault cleared by opening the second line, line 2, what is the accelerating area? Area is dash times of Pmax they are asking. Now see here, if you want to calculate the accelerating area here, see here, we are having, we can calculate the value of delta max, which is nothing but 180 minus sin inverse of Ps by Pmax 3. Here it will be 180 minus sin inverse of Ps is 0.5 Pmax and Pmax 3 is Pmax divided by root 2. So here Pmax will be cancelled. It will be 180 minus sin inverse of 0.5 into root 2. And if you calculate this value, you will get 135 degrees. 135 degrees. So that we got delta naught value and delta max value, and they are asking what is the value of the accelerating area. So what is the accelerating area, students? If you want to calculate the accelerating area, just see here. This is the power angle characteristics, this is delta, and this is the power we are having. This is the mechanical input we are giving, PS, the mechanical input or the shaft power input we are giving here. This is PS. And the initial electrical power will be very high, and after the fault condition we are transferring very less amount of power, and once the fault is cleared, the power transfer will be this one. Clear, right? So initial operating point is this one. From this one the operating point will be shifted to PE2 curve, and it will follow the PE2 curve, and they are clearing the fault at this point, and immediately it will shift to the PE3 curve. So that we are having, this is accelerating area A1, and the speed will be continuously reducing. Finally, it will reach some point here, so that at this point we are having delta max. Clear, right, students? Therefore, this area is the decelerating area. So area A1 is accelerating area, area A2 is decelerating area. To get the stability, area A1 plus area A2 must be equivalent to 0, or area A1 is nothing but minus area A2. Clear, right? So where area A1 is integration of, from where to where you have to calculate area A1? Delta naught to delta CR. It is delta naught to delta CR PS minus PE2 sin PE2 into d delta, which is equivalent to minus of, what is area A2, students? Area A2 is calculated from delta CR to delta max. It will be minus of delta CR to delta max PS minus PE3 into d delta. Clear, right? So that they are asking, this is accelerating area, this is the decelerating area. You can calculate any one. Clear, right? So what are the available quantities? Delta naught is available, delta CR is also available, but PE2 is not available. Right, students? But whereas here delta CR is available, delta max is also available,
P3 is available, right, in terms of P max, right students? Just you can take that one. Therefore, it will be minus of delta CR2 delta max into PS minus P3 is P max 3 into sin delta into D delta. D delta. Clear, right? And this is the area you have to calculate, right? So this is the accelerating area or decelerating area. Both are same only. Both are same. Right, students? If you see this one, so this will be integration of delta CR2 delta max. P max 3 is given P max divided by root 2 into sin delta minus PS is given 0.5 times of P max into 0.5 it is given into D delta, right? So and integrate this one, we will get the value of this area accelerating area in terms of P max, right? So we will get that value approximately it is 0.108, right? So that the area that we are going to get is 0.108 P max. Clear, right? This is one of the way, and the other way also you can do here. So from this side you can calculate PE2 in terms of P max, right? If you do that like that, some students may have done like that, right? So here if you calculate like that, we will get the value of P max 2, we will get it as 0.48 times of P max, 0.48 times of P max, and substitute this value in the above equation. What is that equation we are having? So in this equation, right, not this one. So in the complete equation, right, you will get the value of that one. Clear, students? So that this is the way. So this is the way you can solve this type of question. And it's somewhat lengthy only, but it's one of the easiest question only, right? And you'll see the next question here. So here, so they have given the question in the economic load dispatch, students. The incremental cost curves of two generators A and B in a power plant supplying a common load are shown below. And if the incremental cost of supplying the common load is, incremental cost is given 7,400 rupees per megawatt hour. And what is the common load they are asking. And the graph is given, see here, the graph that has been given here it is approximately like this. So here they have given power in megawatts, and here they have given the incremental fuel cost in rupees per megawatt hour, and the characteristics are given. So it is starting from 10, 20, 30, 40, 50 like that we are having. Like that we are having. And here the starting point is 5,000 and the next one is 6,000 and 7,000. Like that we are having the graph here. Right. And generator A characteristics is starting from this point. And generator B characteristics is starting from this point. So some students are sending generator A is starting from 0. So here we are having 0 somewhere here. Some students are sending from this point, right? So suppose if it is starting from here, you can take that as 10. Suppose if it is starting from this point, you can take it as 0. Suppose if you take from this point, this is generator A and both are meeting at this point. This is generator B, right? So this is for generator A and this is for generator B. They have given approximately, but both are meeting at this point. So which is equivalent to 10,000. That is the approximate graph sent by the students. See here, students. Now, so it is this type of questions already we have discussed, but in the reverse way they are asking here. Clear, right? So previously, in the previous questions, they have not asked about what is the exact values of P1 and P2, which is more and which is less they are asking. Now this time they are asking what are the values of P1 and P2. Clear, right? Or what is the total value. Now just check here, students. This is the starting point of generator A, this is the starting point of generator B. For generator B, what is this point, students? This point will be 10, 6000. And what about this point? 100, 10,000. This is this point. Clear, right? And you can calculate the line equation. What is the line equation we are having? The line equation will be y is equivalent to mx plus c. Right, students? So where m is nothing but y2 minus y1 divided by x2 minus x1. So first of all, we will see for generator B. For generator B, what is the value of y2? It is 10,000, and y1 is 6,000. It will be 10,000 minus 6,000 divided by x2 minus x1. x2 will be 100 minus 10. It is not approximately 10. It may be given nearly if it is 10, right? It is 100 minus 10, x2 minus x1. So it is 4,000. It's 0, I think so. 0, I think so. They have sent from this one also. This is also from 0 point, right? So if it is 0, not 10, it will be 0. It will be 4,000 divided by 100. It will be 40. 40, right? 40 is the answer. Some students send it as 10, some students send it as 100. If it is 100, it will be, that is, if it is 0, it will be 40. If it is 10, take that value. We will get 400 divided by 9, right? Based on the value what you got. This is the slope. Therefore, what is y? So what is the y-axis? The y-axis we are having here, it is the incremental fuel cost of plant 2. So IFC of plant 2 is nothing but m is slope, 40 into x-axis will be the power of generator 2 P2 plus some constant. What is the starting constant? Starting constant will be 6,000, right? It will be 6,000 we are going to have. Clear, right? And this value must be equivalent to lambda. And this lambda is given here 7,400 rupees per megawatt. This will be 7,400 rupees per megawatt. Therefore, 40 P2 is nothing but 1,400 and P2 is nothing but 1,400 divided by 40, right? So nearly we are going to get approximately this value is nearly, it will be 35. It is by 35 megawatt, right? And depends on the point where you are going to start this one, right? If you are starting at this point or if you are starting somewhere here, so based on that one you have to calculate the value of generator 1. So here for generator 1, if you are calculating the slope, right? If you are calculating the slope for generator 1 and the m will be 10,000 minus 8,000 divided by, it is 100 minus 0 or 100 minus 10. That will be given in the question here. Suppose if it is 0, it will be 2,000 divided by 100, so that it will be 20. It will be 20. Right, students. So once you got this one, the incremental fuel cost of plant 1 must be equivalent to slope is 20 into P1 and starting point is 8,000. And this should be equivalent to 7,400. 7,400. Students, see here if you calculate this value, P1 is less than 0. But minimum value of P1, what is the minimum value of P1? It should be either 10 or 0. It depends on the value what you are having. If it is 10, right, the total value will be 35 plus 10, it is 45. If it is 0, the total load will be 35 plus 0, it is 35. Right. So here, so suppose I am writing, if starting point of the generator A, if it is 0, right, if 0 is starting point, then P1 is equivalent to 0. Therefore, total load is nothing but P1 plus P2, it is 0 plus 35. If 10 is the starting point, if 10 is starting point, then P1 is equivalent to 10, that is the minimum value you have to take. Therefore, total load is nothing but 10 plus 35, it will be 45 megawatts. right? Maybe 35 or 45, depends on the graph particularly, right students? And this is the next question they have given. It is one of the previous question given directly. Just previously they have given the resistances, now they have given the impedances. So the impedances of branches 4Z, Z, 2Z and 4Z are given here. So if you see the network here, already they have given E1, E2, E3, E4 like that. Now they have given B1, B2, B3, B4 like that. So we need to remove the branches individually and then we have to calculate. So first of all, we will remove the branch 1 and then branch 2, branch 3 and branch 4 we have to see here. So first of all, remove branch 1. Remove branch 1. So this is the network we are having. So this is I, this is also I and this is also I. And the impedance are given 4Z, Z, 2Z and 4Z. We will take the resistances. So if you take the resistances, it will be 4R, R and it will be 4R. What is the current flowing here students? The current flowing here it will be I, the current flowing here it will be I and here it will be 2I. Right. Therefore, what are the power losses? Power loss are nothing but, so I square into 4R plus 2I whole square into R plus I square into 4R. Right. This is power loss when you remove branch 1. Right. And similarly, calculate remove branch 2. Remove branch 2. So once you have removed branch 2, you will be getting like this. Right. So here we are having I, here we are having I and here also we are having I. Right students. Then here it will be I, it will be 2I, it will be 3I. Right. Therefore, what about the power loss now? The power loss here it will be 3I whole square into, what is the resistance here? It is 4R, 2R and here it will be 4R. It will be 4R, 3I whole square plus 2I whole square into 2R plus I square into 4R. I square into 4R. Like that you have to calculate, remove branch 3 and branch 4. So finally you will get, so whenever you are removing branch 3, then we will get the final solution, right? So that whenever branch 3 is removed, then the losses will be minimum, right students? Just check, cross check like this one, right? And we'll see the next question here. So this is the simplest question I think so in the power systems this year, right? So how many times we have discussed this type of questions? Just check here. So for a 3-bus lossless power system network shown in figure, the voltage magnitude at all the buses are equal to 1 per unit. So that here voltage is 1 per unit. At bus 1, the voltage will be V1 is equivalent to 1 at an angle of delta 1. Here it will be V2 is equivalent to 1 at an angle of delta 2. Here it is V3 is nothing but 1 at an angle of delta 3. They have given. And the voltage phase angles are very small, so that the differences of delta 1 minus delta 2 or delta 2 minus delta 3 you can neglect, very small it will be. And they have given alpha, beta, gamma, delta are the values. So here they have given j times of alpha x, j times of beta x and j times of gamma x are the reactances they have given. If P1 is equivalent to m times of P2, so P1 is m times of P2 and there is no power transfer between bus 1 to bus 2. So in this direction the power flow is nothing, 0. Therefore P1 will have a path like this, P2 will have a path like this only. Therefore what is P1? How to calculate P1? Sending end voltage into receiving end voltage divided by the reactance into sine of angle differences between them. Therefore what is P1 students? V1 V3 divided by, what is the reactance we are having? Beta x. Beta x into sine of delta 1 minus delta 3. And what about P2 students? It is V2 V3 divided by gamma x into sine of delta 2 minus delta 3 we are having. Right. Therefore, they have given the relation between P1 and P2. P1 is nothing but m times of P2 they have given. It is 1 into 1 divided by beta into x into sine of delta 1 minus delta 3 is equivalent to 1 into 1 divided by gamma x into sine of delta 2 minus delta 3. So they are saying that these are very, very small and you can neglect these two and we are cancelling them. Therefore, it will be x will be cancelled. Therefore, gamma is equivalent to beta into m you have here. Therefore, m beta is the perfect answer, right? So gamma is equivalent to m beta, that is the answer. Right students? So these are the questions we are having in the power system, right students? So that's about the question paper analysis of electrical engineering. So based on the memory based, right, questions whatever the students have given, and complete solutions will be available whenever the question paper is available, students, right students? And the ACE Engineering Academy and the ACE online platform is starting. Genco, Transco and Discoms, again a new batch. It will be starting on 19th, right, 19th February 2024. So we are having offline coaching as well as online coaching. So classroom coaching will be available at Abits, right students, and online classes also available. And the timings will be specified when our batch is starting, right students. And for ACE World students, so we are having 50% discount and early bird offer is there 10%. Students who have already listened last time, so we are having 50% discount, and some students are having some major doubts in some portions. You can rejoin and try to get more knowledge, right? Because notification not yet given. That means exam date is not yet given. So try to attend the classes and try to join. Right, students? All the best.